Hey, welcome back to another video starring me. Yippee. Um, so these first problems look a lot like the problems from the first video, video 1. Again, don't just watch me do it, please. Press pause on the video and try to do this yourself. Go on, press pause. Alright, so hopefully you did it, and I hope you got, what? How many of these root 3s are you going to need? 3, 6, you're going to need 7. This should be 7. Okay, it's 7. You actually have an answer key on the bottom of your paper if you didn't notice, so it's obviously 7, but how do you get to 7? Well, I told you. You're doing log base 3 of this whole thing. Go ahead and set this equal to x, or whatever other variable you want to, you might want to think like, well, it's a power. Let me make it p. You can use any variable you want, but it's going to be root 3 to that power of p equals 27 root 3. I don't know why this circle is so big. Let's make it smaller. Let's not make it too small. Let's have a little bit of a circle there. Alright, so now what? We said you need a common base, and just like the very first problem from before, our common base was 5. This time our common base is 3. So you've got... dumb, big idiot. Stupid idiot. Alright, it's going to be 3 to the 1/2. To the p. This is going to be 3 cubed times 3 to the 1/2. So this is 3 to the p over 2, because you're multiplying those powers. Here you're adding these powers, so you would get 3.5, aka 7/2. At which point you can say that if these things are truly equal, and the bases are equal, then the powers must be equal. So you can just say that the p over 2 has to equal the 7 over 2. Then multiply through by 2 to get the 2's to cancel, and you get p equals 7. And that is how you solve that. For the next one, what are we doing here? Why am I not sure? I'll convert. 3/4 to the x equals 1. Right, okay. This one seems weird to me because you basically just have to have this memorized. What power of 3/4 is 1? Well, what power of anything is 1? It's always 0. So this was actually a log we should have been able to evaluate just by looking at it. We're supposed to know that log base anything of 1 is always going to be 0, because it's the 0 power that turns things into 1. So number 2 was easy. This one, let's do the same old thing we always do, convert to exponential. We'll go 3 to the 3/2. That's supposed to equal root 7. So at this point, if you want x alone, then I would raise both sides to the reciprocal power. So these cancel, you get x. Now I think in the past I've told you that with these powers you take the root first and then you apply the power. It doesn't have to be that way, and in fact this time it shouldn't. You've got this root 7. Let's do the squaring first and the 1/3ing after. Because now, squaring the radical just gives you plain old 7. And 7 to the 1/3 becomes cube root of 7. Hopefully that's it. Yeah, of course that's it. The only other thing I was thinking of was, since we're squaring, could we let our base be negative? But no. Even if we had plus or minus, we couldn't let it be minus because our base can't be negative, and it's not anyway, so I'm just being a fool. Let's put a nice little dividing line. Then let's try to do this problem. This looks pretty darn similar to the problems from before. You get a 2x to the 2 equals 28. And just like the other problem that looked like this, don't forget you're raising the entire base to the power of 2. So you got to square the 2 to get 4. You got to square the x to get x squared. It equals 28. Apparently we like 7s around here because x squared is now equal to 7. So you take the square root, generating both a plus or minus root 7. But again, your base can't be negative. So throw the negative root 7 out as extraneous and state that the only actual solution is root 7. Positive root 7. Ugh, 5. Alright, convert to logarithmic. 3 to the 3 is 27. I said convert to logarithmic. I meant convert to exponential. So you get 27 equals x squared plus 2. Subtract 2. 25 equals x squared. Take the square root. X equals 5. But is that all? No. Negative 5 too. Now, are we solving for the base? Nope. So negatives seem to be okay. Are we worried about our argument being negative? Well, yes, we're worried about it. But plugging in negative 5, you square it, you get positive 25. Plus 2 is 27. And log base 3 of 27 is indeed 3. So this negative answer is not extraneous. It's fine. Because, again, plugging in a negative doesn't mean you actually get a negative. So both of these answers are correct. So as a solution set, you can be the negative 5 and the 5. Alright, so here's these sort of nested logs, which we said we're going to want to work our way out from the inside out. So log base 3 of 81, maybe you don't know the answer, but I hope you do. 3 to the 1 is 3. 3 squared is only 9. 3 cubed is only 27. 3 to the 4th, let's see, that's a 3 and a 3 and a 3 and a 3. If you're a smart person, then you group those off and you can see that 3 to the 4th is a 9 times a 9, which guess what? That's 81. So log base 3 of 81 is just 4. So that means you're looking at log base 4 of 4. Now if you're working your way from the inside out, then you're doing log base 4 of 4, which of course is just 1. So you now have log of 1. Oh, by the way, the equals x part is kind of irrelevant. You almost want to just take that away. And instead of thinking of this as an equation to solve, just think of it as an expression that you're trying to evaluate. You're just trying to find the value of this. And then, of course, whatever you get will be x. So keep on keeping on. This is x. Now, there's no base printed here, but just like if I said, find me this. I didn't mean that. My brain got ahead of itself again. But if I said evaluate this, you wouldn't come to me and go, Mr. F, is this supposed to be a cube root or a fifth root? You know that when there's no number here, it's a 2, it's a square root, right? You don't write 2's on radicals. It is understood that they are square roots. If you want a different root, like a cube root, then you have to write that. Logs are the same. The log here has an understood base of 10. You don't write the 10. Everybody knows that when there's no base, the base is 10. You only write the base when you want something else, like 3 or whatever. So this is a log base 10 of 1. And guess what? It doesn't even matter what the base is, because the log base anything of 1 is always 0. So if you forgot that a log has an understood base of 10, you still could have done this problem, because even if the base was 147, then log base 147 of 1 is still going to be 0. So number 6 is 0. Moving on. Ooh, another, wait, that's not even different. You're just the same guy twice? Log 4, 381. Log 4, 3, yeah, okay. Oh, but it's log x. It's log x instead of x. Okay, so that's somewhat meaningful. So since we just saw this, we saw that it's going to boil down to the log base 10 of 1. And that's going to equal the log base 10 of x. Alright, again, call me crazy, but the 1-to-1 rule seems to apply here. If these expressions are equal, and if the bases are equal, you can essentially just kill the logs and say that if everything is equal here, then these two things must be equal as well. So 1 must be x. And that's fair. That's legitimate math. Once you've gotten any equation boiled down to where you have the log base b of, I don't know, m is equal to the log base b of n, as long as the bases are the same and as long as there's nothing else, there's no coefficients, there's nothing added on, then you essentially can get rid of those log base b's. If you're curious what the actual algebraic step is that you're doing, It's called exponentiation. You make these things powers on whatever the base is, because b to the log base b of m is just m, and b to the log base b of n is just n. So if canceling the logs didn't feel quite right to you, then, I mean, this doesn't feel right to you either, probably, but that's technically what's happening. The other way to justify it is you are using the one-to-one property, which says that logs are one-to-one functions. So if the log base b of m is the same as the log base b of n, then m must be the same as n. That's a rule. All right, next. This seems fine. It's not very fine. What's the log base 3 of x? Something I can't evaluate. So we like to work our way out from the inside, but for this problem we just can't. So I've got a new plan. Pretend this was just a log, and the inside was normal. Wouldn't we convert right to exponential notation? We'd be like, okay, let's say that 5 to the 0 equals whatever we had in parentheses. Well, what we have in parentheses is log base 3 of x. So we sort of resolved the outermost log by just turning it into exponential. And now 5 to the 0 I can evaluate. 5 to the 0 is 1. So now I can convert to exponential notation again. And I'll get 3 to the power of 1 equals x. And 3 to the 1. Oh, what is that? Oh, geez, I need to calculate. No, it's 3. So you're done. You know that this thing, x would have to be 3. For 9, I don't know, dude. Call me crazy, but you probably shouldn't forget how to just do basic algebra. Subtract x from both sides. That'll isolate this log for you. Not that you needed to. This is now x. This is just an evaluatable log, though. I mean, what power of 2 makes 16? Pretty sure 2 to the 4th is 16. So I'm pretty sure log base 2 of 16 has a value of 4. That's kind of anticlimactic for being the 9th in a set of 9. You'd think that would have been harder, but no, wasn't. All right, this says do the following functions model growth or decay. Biggest thing for me to say here is growth does not equal increasing. Got it? Growth does not mean increasing. Growth does mean does equal a base that is greater than 1. But that's not quite true either. It means growth happens when your base is greater than 1. When C is positive. Exclamation point. So where is that relevant? That's relevant here. This is our C value. In case you forgot, our exponentials are a times b to the x. So if we're trying to oh God. If we're trying to slide our transformations in, I've been talking too much, I guess. But a literally is a, the transformation. And then your base b is not a transformation, that's just b. You've got an x upstairs. Then you've got a transformation here. Your coefficient on x is your c value. Then anything added on to x, technically subtracted, that's the h. And anything on the outside added on is a k. So what I'm trying to say is, someone's going to fall into the trap of looking at this and saying, ooh, the base is 7/3. 7/3 is greater than 1, so this is growth. And you're going to be all proud of yourself, and you're going to be wrong. Because we can't let our exponents contain negatives. We have to resolve that negative taking the reciprocal of the base. So before you make a decision about growth or decay, you need to rewrite this function in a simpler form. It's got to be 4 times a base of 3/7 to a now positive power. So now we check this box of c is now positive, but now we're looking at a base that's less than 1. And of course, that's decay. Decay is when you have a base that lives between 0 and 1. So since 3/7 is less than 1, bigger than 0, this function models decay. That's the tricky one. The rest should be cake. Looking at A, there's not a negative sign in sight, so we're in the clear. Our base is E, so hopefully you just remember that E is worth 2.718, which is decidedly greater than 1, so this is a growth model. Now part C, there's no negative in the exponent. Negative A values I'm not really worried about. They don't really come into play at all. My base is 10, and 10 is greater than 1, so this is a growth model that just happens to have been reflected. So it's a growth model that just so happens to decrease. But that doesn't change my answer. I'm still calling it a growth model. It's not decay just because it goes down. It is still growth, which is tricky and weird and stupid, and it seems like a semantic argument, but it's a fact. So choose growth, even if it decreases. All right, did that one. Moving on. So we get now to another half-life question, which I told you guys I didn't like this one, and we did it in class. So if you're watching this and you still don't understand this, then let's just get rid of the s sub 0 grams, and let's do this problem. More less generally, I guess. Let's do it more specifically. Let's make up an actual initial value. Oh, I want to be done talking. The initial amount of substance is 42. Didn't we have 42 already? Doesn't matter. 42 grams. Everything else can stay the same. So it says express the amount of substance S remaining as a function of time. So amount of substance over time would be S of T. It's always going to be, it says it right here, the initial amount, which is given to us. Oh yeah, I just made it up, 42. Let's take a 42 here. We're talking about a half-life problem, so the most convenient base to use would be 1/2 itself. Then we raise that to the power of time. But you have to divide time by whatever your half-life is, 2.5. So there's a 2.5 in our exponent, in the denominator of our exponent. But there's your model. So now, part B is kind of just a quick concept check. They're really just asking, hey, do you understand half-life? Because if you do, then you're going to notice that 2.5 is literally the half-life. So guess how much substance is left after one halving period? It's going to be half. You're going to be down to 21 grams. And hopefully you also notice that 7.5 is 3 half-lives. So the 42 is going to get chopped in half 3 times. It's going to be 42 down to 21 down to, don't judge me here, 10.5 down to 5.25. That feels right to me. By the way, that's a dumb way to do this. You should probably know that 1/2 3 times is 1/2 cubed. That's 1/8. So to get here in the first place, we could just be doing 42 divided by 8. And just to double check that is the right answer, right? 42 divided by 8. Yeah, 5.25 grams. So that's it. So a better question might have been, hey, how much is left after like 6 seconds? Because you know that 6 seconds, we're going to have chopped it in half once and then twice, but not a third time. So you should be expecting an answer that falls somewhere between 10.5 and 5.2. It's not something you can just do in your head. But that's what the rule is for, right? So if we were trying to do this thing after 6 seconds, you know you're just looking for s of 6. So you just do 42 times a half to the 6 divided by 2.5. Now again, we won't ask you this on the quiz because to do this you would really need at least a scientific calculator, and you're only going to have your 4 function. But you can imagine a world where you could evaluate this, right? You just do the 6 divided by 2.5, you raise a half to that power, you multiply by 42. So rather than imagining such a world, we can do it super quick. I said to do, well, we could type the whole thing in at this point. Let's play it like we only had a scientific calculator. So you figure out what is 6 divided by the 2.5. It's that. So I would be doing a half to that power. So 1/2 to the power of 2.4 gives me that. And then I'm multiplying that by my initial amount, 42. So we're down to 7.958. So just in case you were wondering. And that does make sense because like I said, 6 seconds, we would have already halved once. That would take us 2.5 seconds. By the time we got here, we would have halved twice. That would have been 5 seconds. By the time we got here, we would have halved it 3 times. That would have taken us 7.5 seconds. And I asked you how much junk there would be after 6 seconds. So that obviously lands us somewhere between the 10.5 and the 5.25. And so getting an answer of 7.958 should feel great to you. That should feel like it fell exactly where it should have fallen. All right, let's do part C. It says oh, I guess we can't really do this, which is fine. We'll just change this question around. This question, if we already knew S naught. I just said something I've been trying not to say. But S sub 0 is also called S naught. N-A-U-G-H-T. Not like the English word, like meaning actually coming from England. They say this over in England a lot. Instead of 0, they say not. Kind of like nil. I don't know if they're giving you like a soccer score, they'll be like, yeah, the score was 2-0. When do they say not? I don't know. Obviously people will say, all my efforts were for naught, right, if they failed. I did all this work and it was all for naught. Anyway, I'll shut up now. Every once in a while you might hear that slip out of my mouth. When I mean S sub 0, I'll say S naught. And I don't know. Now that I've explained it, maybe I'll just say it more because it's what I prefer anyway. Oh my god, shut up and just do the problem. What would this last problem? Oh, there's actually more problems after this. This would just be one of those problems where I ask you to solve for the time when the amount of substance has decayed down to a certain spot. Let's say 10 grams. So how long that's not a double L. How long until less, it is correct to say less here. How long until less than 10 grams? And, we've talked about this. We would set the whole function equal to 10. So 10 equals 42. 1/2. T to the t divided by 2.5. We had the 2 schools of thought on this. We said we could just let this side be y1. We could let this side be y2. We could graph them together and look for the point of intersection. But that's not going to fly on your quiz. So you have to solve this manually. So you'll divide on both sides by 42. Those will cancel. You'll get a fraction that you can reduce, so reduce it. It'll be 5 over 21. And that's going to equal 1/2 to the t over 2.5. You're now at a point where you've got a basic exponential, so convert it to a logarithm. It's going to become a log base 1/2 of the 5/21, and that's going to equal t over 2.5. So you just multiply both sides by 2.5. By the way, 2.5 is just 5 over 2. So you could give me the answer as 5/2 times log base 1/2 of 5 over 21. And if you gave me that, that would be lovely. I see that I'm off the grid, or I'm not on the screen, but now I'm back on the screen. You could also give me the slightly more lovely answer of 5/2, and then use that rule I said, where if you want to take the reciprocal of the base, you can, as long as you also take the reciprocal of the argument. So log base 2 of 21/5. Neither of these answers is actually better than the other. Stopping here is perfectly fine. Giving me the red is fine too. Anyway, that would be the answer. You would not be expected to evaluate it. You'd be expected just to give me that expression, including the log, including the 5 over 21. Leave it alone. That's the answer. Are you curious what it's worth? I don't think I care if you're curious, but fine. Let's do it. Zoinks. So what are we doing? We are evaluating this log. So you'll type 5/2 first. That didn't automatically make a fraction. Fine, I'm doing the 5/2 last. We said math. Then to get to the log that you want, you have to scroll down, because we need a log with a special base. So choose that. Log base 1/2 is log base 0.5. 5 over 21. Okay, so it's that, and then this is going to be multiplied by 5/2, so times 5 divided by 2. So it's 5.176 seconds. Yeah, okay. That again is something we knew. How did we know, you wonder? Well, it's back over here. Didn't we already say that after 5 seconds would be at 10.5? So when are we going to be at less than 10? I guess it would be very shortly after 5 seconds, right? So somewhere between 5 and 6 seconds probably. And we got 5.17. So that jives. That makes sense. All right, I'm done with this forever. Let's go to the next one. This one says, the relationship between intensity I of light in lumens at a depth of x feet in Lake Superior is given by log of I over 12. Equals negative 0.0125x. So this is the equation for light intensity in Lake Superior. It just is. That's it. So they just want to know, what is the intensity at a depth of 10 feet? Well, x is the depth. So they're essentially just giving you the value of x and challenging you to solve for I when I is stuck inside of a log expression. So fine, I can do that. This will be log. By the way, log with no printed base is log base 10, called a common log. I over 12 equals, if I let x be 10, then I'm just moving the decimal point over once. So this becomes negative 0.125. I think I did this in class for one of the periods, but if you knew, 0.125 is exactly 1/8. So it might be in your best interest to just turn that decimal into the fraction, negative 1/8. Now that 10 right there, we're converting to exponential. So we end up with 10 to the negative 1/8. And it equals I over 12. So to solve for intensity, we just multiply through by 12. So you end up with 12 times 10 to the negative 1/8. Honestly, that answer, as is, seems fine. You could do slightly better, I guess, because you could apply the negative to make the base 1/10. Now you're positive. Then you could be taking the 8th root. So should you be giving me 12 times the 8th root of a 10th? That doesn't seem great, right? Doesn't seem great. I don't know. It could be 12 over the 8th root of plain old 10. That's not great. Honestly, I think the way it was fine. 12, 10 to the negative 1/8. That is our intensity. Without a graphing calculator or a scientific calculator to evaluate this, you leave it alone. Give me the answer just like this. It's fine. Well, not just like this. Lumens. Make sure you give me your units. The light intensity is being measured in lumens. Which maybe shouldn't feel strange if you've changed the light bulb recently, because our old incandescent bulbs used to be in watts. But you've probably noticed that your LED light bulbs, they don't use watts. They're measured in lumens. So maybe that felt familiar to you, maybe it didn't. Moving on. Is the following equation exponential growth or decay? Well, we talked about that. I do see a negative on x. I mean, this thing is horrible. Maybe you can't even read it. But it's 5, 2. I would flip-flop these terms so that I have negative x plus 4 plus 2. Then I'd be sure to factor the negative out before I did anything crazy. So it's negative x minus 4 plus 2. Now I can apply the negative to the base. And I can see that my equation is actually 5 times the base of 1/2 to the x minus 4 plus 2. At which point I'm ready to answer, are we growth or are we decay? We are decay. Because our base is less than 1, now that we've factored out the negative and applied it to our base. It says find a formula for the inverse. Oh, I don't want to. Find the domain and the range. Fine. So if this is our function f of x, then of course to find our inverse, the first step is to flip the variables. So we're going to let f of x be x, 5, 1/2, y minus 4 plus 2. We said we want to isolate this exponential base, so we'll subtract 2. Then to get rid of the 5, I'll multiply through by 1/5. So we've got our exponential isolated now, which means now is a great time to convert to logarithmic form. It's going to be a log with a base that's equal to the base, so 1/2. We're going to be taking the log of what we were equal to, so the 1/5, x minus 2. And that's going to equal the y minus 4. So I'm going to be a little lazy and say if this was equal to y minus 4, then we would have added 4 to just isolate the y to get the inverse function. But there it is. This log function is our inverse function. So that checks bullet 1. Now find the domain of the inverse. Well, the inverse is a log function. So the domain is going to be dictated by the vertical asymptote. The vertical asymptote is dictated by the argument. So when will 1/5 of x minus 2 be equal to 0? At 2, of course. 2 is the 0. So 2 is where the asymptote is. So there's only one last question. Is my domain going to be 2 to infinity, or is it going to be negative infinity up to 2? And that depends on if there's a reflection, and there's not a reflection. There is no negative in front of x that will reflect us. So since there's no reflection, since my base is 1/2, you should be expecting this graph to decrease. Kind of looks something like this. But the long and short of it is your domain is 2 to infinity. And of course your range is all reals. And it says the equation of the asymptote of the inverse. Well, it's a vertical asymptote at x equals 2. So there's this whole problem sorted. Last one feels pretty good. Another problem. So I don't love this, actually. On your quiz, I'm not going to give you anything with an ln. Because again, you don't have a calculator to evaluate the e's with. So this really needs to be something else. Fine with the -3. So let's go -3. It needs to be sort of a reasonable log. When I say reasonable, I guess it would be like 1/4, 1/3, 1/2, or 2, or 3, or 4. Maybe 5, maybe 6. Let's do a 5. Okay, it says what's the equation of the asymptote of the original function? Okay, fine. Same rule. You still want the 0 of the argument. So 12 minus 12 would make 0. How would I get 12 here? 18. Nailed it. How would you kids that can't do math in your head do this? You'd grab the whole argument. That's fine. It's not a problem. 2/3 x, and you'll set it to 0, and you'll solve. I would add the 2/3 x, just to keep everything positive. Then you'll multiply by the reciprocal, 3/2. 2's cancel, 3's cancel. You've gotten x. Now here, this is over 1, so this is 36 over 2, which, as I told you, is 18. So we know that our asymptote occurs at x equals 18, and it's vertical. So that means our domain is either 18 to infinity, or it's negative infinity to 18. I do see a negative coefficient on x, so I do expect my graph to have been reflected over the asymptote. And with a base of 5, this is confusing, but with a base of 5, it would have increased, but then somebody reflected it, but then somebody reflected it again, so it's going to go like this. It will have this shape. You don't need to know that. You do just need to know that the domain is definitely negative infinity to 18, rather than 18 to infinity. You also know the ranges are reals. You also know that to find your x-intercept, you're going to let y be 0 and solve for x. To find your y-intercept, you're going to let x be 0 and solve for y. So if you know that x is 0, that's probably the easier thing. You're just going to substitute x in up here and see what happens. So you'd have -3 log base 5 of 12 minus, if you plug it in 0, obviously 0, minus 8. You just can't evaluate this. Even when it was ln, you couldn't. It's just literally going to be log base 5 of the 12. That's not evaluatable, because there's no clean power of 5 that gives 12. How do you know that? Well, 5 to the 1 is 5, and 5 to the 2 is 25. So obviously, if you were trying to get 12, that's 25. If you were trying to get 12, you'd have to be doing 5 to the 1 point blah blah blah. It's not an integer value. It's going to be something ugly. And since it's ugly, you're allowed to leave it alone. And the rest, you can't do anything with it. So as dumb as this is, that's your answer for the y-intercept. -3 times the log base 5 of 12 minus 8, which you just can't simplify without a calculator. For the x-intercept, if we set the whole thing equal to 0, what's going to happen? What are we going to get? I don't know. Take your function, -3 times the log base 5 of 12 minus 2/3 x minus 8, and set the whole thing to 0. That's how you'll find your x-intercept. So you're definitely gonna add the 8 and then divide by 3. That'll give you log base 5 of 12 minus 2/3 x. So it's going to be positive 8 but then divided by a -3, so it'll be -8/3. Now that your log is isolated, you can just convert to exponential. So you now have 5 to the -8/3. Which is ugly. I know it's ugly, and I wouldn't even try to evaluate it, but it's equal to 12 minus 2/3 x. So to solve, I don't know. Again, I don't like negative leading coefficients. So maybe add this to the other side. So you now have positive 2/3 x plus this stuff. This is gone now. So now to isolate x, you're going to subtract the 5 to the -8/3. So you've got your 2/3 x equals 12 minus 5 to the -8/3. And then to really finish this off, you just multiply through by 3/2. So cancel, and you just get x. Do distribute the 3/2, and you get 18 minus 3/2, 5 to the -8/3. So yeah, it's ugly, and I have no idea what it's worth. But that's it. That's the x-intercept, whatever that comes out to be. Alright, that's a lot of video recording. So I'm going to be done. You kids are going to be thankful. I hope you're going to be thankful. Yeah, whatever. Let me know if you got questions. I guess you can try to hit me up via email. You can ask questions in the comments. I do kind of check in on the video to see who's been watching, and I look for my thumbs up, and I look for my comments to see who's, really using this resource. So if you have questions, you could ask them there. I'll try to answer them. Anyway, good night.